Hello everyone and welcome back to my tutorial about scaling large React applications. Today we will talk about something that is critical but often overlooked: security and compliance in large React apps. So if you are worried about bugs and vulnerabilities hiding in your dependencies or audit for regulations such as GDPR, this episode is for you. I'll share some practical approaches that will keep your users and your business safe. So let's get started. Security issues usually don't hit Hello World apps. They show up when your product and team grow and when real user data and money are on the line. And then small bug can turn into a big breach, and violation of privacy laws and regulations can ruin trust or even your whole business. And as your code base grows, so does your attack surface. You have more inputs, more dependencies, more users, and more risk. But the good news is that thinking about security and compliance on the early stage is a huge investment in your peace of mind. So let's break down the main threats you need to protect against. The first one is cross-site scripting, and this is still your enemy number one. Every time your app renders an untrusted HTML or user input, you allow attackers to inject their scripts. In React, always use the default rendering for user input. Never use this dangerously set inner HTML option unless you absolutely trust the content, and always sanitize it before rendering. And cross-site request forgery is less common now with all the modern APIs and token auth, but if you use cookies for authentication, then make sure your backend validates tokens and uses same-site cookie flag. And make sure you never expose any sensitive data in your code. API keys, passwords, or access tokens, they never should be in your front-end code. Use environment variables and server-side logic to keep all this kind of data out of client build. And avoid open redirects and insecure routing. Never trust URL parameters blindly when you redirect your users. You should validate all the paths on your server side. So these were some general security threats, and now let's focus on React. There are some good habits that can help you to write safe React code and make sure you stay secure. React escapes all your content by default, and make sure you do not opt out until it's absolutely necessary. And never interpolate unsanitized user input into JS6 or HTML. Validate all user input. You can do it on both client side and your backend. And be careful with all the third-party widgets, especially if they can access your DOM. And review your permissions approach. Never expose any admin features, just checking for is admin on frontend. Make sure you enforce the permission check in your APIs and server as well. A huge chunk of React attacks comes from the supply chain. That is vulnerabilities in your NPM packages. So what you can do? Run NPM audit or yarn audit regularly, including your CI/CD pipelines. Use Dependabot or Renovate. These tools can alert you about the vulnerabilities and outdated packages and even raise PRs to update them automatically. Enforce strict peer dependency control. Use only well-maintained, proven packages and track what each dependency is actually doing. And of course, commit your log files to prevent accidental dependency upgrades and coordinate version bumps across your teams. And what about compliance? If your application processes data from Europe, US, or any other regulated regions, you should care about compliance. There are a few principles you have to follow. First, privacy by design. Only collect the data you truly need and be upfront with users what you store and why. Remember about the data subject rights. Implement the way for users to download or delete their data if required. Be mindful about logging. Make sure you log all the sensitive actions securely, for example, like logins or role changes, and keep your logs off the client. Take care of your cookie consent management. Use clear prompts and store the consent preferences, especially for analytics and advertisements. Review your storage. Don't keep any sensitive data in local storage or any other persistent storage in the browser. Assume that anything in the browser can be accessed by the attacker. And don't forget to review all the third-party integrations. Make sure any tracking, analytics, or payment providers you use have compliant privacy policies and data handling. You can make security everyone's responsibility, but much better to automate it. Integrate security checks in your CI/CD pipeline, lint for common security bugs, run automated dependency audits, and test for vulnerabilities before the code merges. You can make use of code review checklists. Include security questions there, such as, is any user input rendered dangerously? Or if all the secrets are safe. Use static code analysis tools such as Sneak and SonarQube, or open source scanners like SamGrep. They can help you to catch security bugs in build time. And run penetration testing regularly. There are tools that can simulate a real attack. And if your project is large enough, you can combine these tools with bug bounty programs, for example HackerOne, to crowdsource additional scrutiny. Even with the strong preventative measures, incidents still happen, and a well-prepared response plan can limit the damage, keep users informed, and help your team to recover quickly. So you have to have an incident plan. Think of it as your guide for when the breach or critical vulnerability is discovered. First of all, define roles and contacts. Identify a response team. It could include an engineering lead, security officer, legal counsel, and PR or communications lead. Keep their phone numbers and emails in the accessible location. Next thing you need to take care of is documentation. Document the steps to isolate the affected systems, revoke credentials, and roll back deployments. Prepare runbooks for emergency releases, including how to cut the hotfix branch, trigger the CI/CD pipeline, and test critical patches under time pressure. Legal and regulatory communication is also important here. Understand your obligations for GDPR or other compliance framework. Create templates for notifying regulators and affected users within the required time frame. And draft holding statements and frequently asked questions in advance. Transparent and timely communications will help you to preserve trust, even if data breach happened. Another thing you can do is to run regular incident drills. This practice ensures that your team is able to act fast even when the adrenaline is over the roof. So simulate scenarios, for example, leaked API key or ransomware attack, and walk through the response as a team. And after each drill, understand what slowed you down. Missing contact information, unclear roles, or lack of tooling, and update the incident response accordingly. And remember, security and compliance are never done. They are a continuous part of your workflow. So keep learning. Attackers are creative, and regulations often change. Budget time and resources for proactive security work, audits, education, and testing. And reward responsible disclosures. Foster a no-blame culture for bug reports and incidents reviews. and support your team in making the right, even if inconvenient, security choices. And that's it for today. I hope you found this video useful and it will help you to avoid any security incidents in your application. And in the next video, I'm going to talk about another very important for large applications thing, refactoring of the legacy code. So if you're interested, stay tuned and don't forget to subscribe for my channel.